Hi students, now we are going to go through the topic cells connected in parallel. You can see here the EMF of each cell is E and the internal resistance of each cell is small r. So all these cells are called as identical cells, and the positives of all the cells are connected together and the negatives of all the cells are connected together means then we can say the cells are connected in parallel. In addition to these internal resistances, we have connected one external resistance capital R in the circuit. Now here also we want to get an expression for the effective current supplied by the battery. This combination of n identical cells in parallel is called a battery, and what is the expression for the current supplied by the battery? So as usual we want to find the effective EMF or the net EMF. So the effective or the net EMF in this combination of n identical cells will be equal to E itself. We have studied the cells connected in parallel, isn't it? So EMF of one cell is E. Therefore, EMF of the net combination of n identical cells also is equal to E. So this must be the first expression for us. Now, small r is the internal resistance of one cell. Therefore, I will find the combination of this. So 1 by small r equivalent. This is equal to 1 by r plus 1 by r extended up to n number of terms. So this is equal to n divided by r. Therefore, what is small r equivalent? This is the equivalent resistance of only the internal resistance. So this R equivalent must be equal to what? R divided by N. So this is our second step. In addition to this small r equivalent, what also is there is capital R in the circuit, is it not? Therefore, the net or the effective resistance in the circuit is equal to this R by N plus capital R. So if you take LCM if you take means this is small r plus n times capital R divided by n, and this is the third step. So what is the expression for the total effective resistance in this entire circuit is equal to the effective internal resistance plus the external resistance. So if you take the LCM, it is R plus n times capital R divided by n. Therefore, what is the effective current? Now, the net current supplied by the battery is given by I is equal to the net EMF divided by the net resistance. Okay, what is the net EMF? Net EMF is also equal to the EMF of a single cell E divided by what is the net resistance is small r plus n times capital R whole divided by small n. Now this denominator n can be shifted to the numerator. Therefore, the final expression for the effective current is equal to n times capital E divided by small r plus n times capital R. So this is the required equation number 3 for us. Now, did you notice the third equation? The third, I can call it as fourth. Already third is existing. Okay, the fourth equation. Now, this similar expression we have derived for the cells in series. There we got the expression current is equal to n times EMF divided by small n times R plus capital R we got. But here the reverse is coming in the numerator. Small r plus n times capital R. This is the only difference you can remember. Understand that? Now the special cases. What is the special case? So case 1. The internal resistance R is very much smaller than the external resistance. So in this case, when R is negligibly smaller than capital R, here small r can be eliminated. Okay. Therefore, what is the expression for current I is equal to N times E divided by N times R. So this N is getting cancelled. This is equal to E divided by R. So this is nearly equal to the current supplied by a single cell. Is it not? Therefore, current supplied by the entire battery, current supplied by the battery is equal to the current supplied by a single cell. Current supplied by a single cell. As if there are n number of cells connected in parallel, the current is equivalent to what is supplied by single cell itself. So is there any advantage in this case? There is no advantage. Okay, so no advantage in this case. So in which case there is no advantage? When R is very much smaller than capital R, there is no advantage. Now what is the next case? Case 2. So we will take a small r is negligibly smaller. External resistance capital R is negligibly smaller than this internal resistance. That is a case 2. Okay. So in this case, children, in equation 4, which has to be neglected is capital R. When I neglect capital R, therefore what is current I is equal to N times E divided by small r. So this is equal to N times E divided by small r. The EMF E divided by small r is also nearly equal to what? The current supplied by a single cell. So this can be assumed to be equal to what? N times I1, where I1 is the current supplied by a single cell. Therefore, here current supplied by the battery, by the entire battery is equal to N times the current, N times the current supplied by a single cell. So this is more advantageous. Okay, this is advantageous. So you have to now remember 2 points. When the cells are connected in series means when is that combination having advantage? When small r is negligibly smaller than capital R. But when the same number of n identicals are connected in parallel, when is the advantage? When the external resistance is extremely smaller than the internal resistance of each cell. Understand? So I hope you must have understood well. Fine.